Hey guys, this is Miss Mo. Let's get this review done. Okay, so the first one is a picture, so I went ahead and printed it out big. Okay, so it says the limit, blah, 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 all about -1. So let's find where -1 is on this picture. It says x approaches -1, so when x is -1, we're looking at this portion of the graph. And when it says -1 from the plus, that means to the right. So if I'm looking at this x value of -1, to the right of it is this sucker directly attached to it. Not this big old curve on the right, because it's not directly attached to it or as close to it as possible. So when I'm looking from the right, I don't want to look way over here on the right. I want to look for my x value of -1 and then look for the piece of the curve that's directly to the right of it. Okay, so this is the limit as x approaches -1, and we're looking from the right. And remember that limit means the y value. So right here, when x is -1, y is up 1, 2, 3, 4. So this is -1, 4. And that's the piece directly to the right. So the limit as x approaches -1 to the right is that y value, 4. Now let's look at this next sucker. It says -1 from the left because of that negative in the air. So here's my -1. When x is -1, it's this highlighted line, and we're going to look at the section directly to the left, like directly attached to it, right here. Yeah, I'm not going to look way up here. I'm going to look directly attached, directly to the left. So this is my left curve, so I'm going to look at this left curve to find the y value. When we had x approaches -1 from the plus, that meant I have to look at the right-hand curve and find his y value. But now I'm looking at this left-hand curve, and it looks like it's at left 1, down 4. So the limit as x approaches -1 of this left side is -4 because it's the y value. Then when you say, okay, well, what about as x approaches just -1, no plus, no minus? Well, this one is going to be does not exist. And it does not exist because these last two suckers from the left and the right were different. If they were the same, then the third answer would be that same number. But since I have two different y values, the limit as x approaches just -1 does not exist, because if you look when x is -1, there's two y values. There's this open hole at the top and this closed hole at the bottom. Well, you can't have two y values, so the limit does not exist. And the last one, f of -1, that means look for the closed hole when x is -1. So let's go to -1. It's this highlighted, and we're going to look for the closed hole. And the closed hole is right here. And the y value of that closed hole is down 1, 2, 3, -4. Yay. Okay, let's go to number 2. Number 2 says the limit as x approaches -6, and then they give us 2x plus 3. Well, it's the same-ish thing. When our x is -6, we want to know the y value. So I'm just going to take this -6 and plug it into this equation. 2 times -6 plus 3. And I think that gives you, let's see, 2 times -6 is -12, plus 3 is -9. Hey, that's the limit. And I bet if I plug this 2x plus 3 in my calculator, and looked at the x value of -6, I bet the y value is going to be -9 because that's what a limit is. It's the y value. So check it. I put 2x plus 3 in my graphing calculator. I go to my t-chart. Across from that x value of -6 is -9. Whoa. So the limit is just the y value. Okay, let's look at part number 3. First, we're going to try and plug in that -5, and you might be kind of scared, but it's okay. On the top, you have to put parentheses around that -5, or your calculator is probably not going to give you the right answer. And then on the bottom, we have 5 minus, and then my x value that I'm plugging in is this -5. Okay, so let's see what we get. On the top, I think you get 25 minus 9. On the bottom, this double negative makes a positive, and we get we get 10. Sorry. So we get 10, and 25 minus 9 is 16 over 10. And then you can reduce, and you get 8 over 5. Okay, whether you did that in your head or your calculator, just make sure that when you press math, enter in your calculator, you get 8 over 5. Okay, let's look at number 4. Okay, it says f of 0 equals 2. And if you remember from those pictures we talked about, when you have f of a number, that's a closed hole. So we are going to have a closed hole at f of 0 equals 2, or 0, 2. So let's go ahead and put a big fat dot at 0, 2. That's 0 left, right, up 2. Big fat closed dot. Hey. Okay. Now let's look at this middle. It says the limit as x approaches 0 from the negative, the left, is 3. So that means the y is 3 for the left curve. Then the next sucker says limit as x approaches 0 from the right is 2. That means your y is 2 from the right curve. Well, we need curves. I don't have anything. All I have is a closed dot at 0, 2. Well, let's think about this. It says on the right side of this x is 0. So 0 is right in the middle. That's when x is 0. And the right side of the curve should have a y value of 2. So here's a y value of 2. And that means the right side of the curve is going to be directly attached to that closed dot at 2. But then if we look, it says the left side of the curve is going to come and have a y value of 3. So let's put that y value of 3. Here she is. Okay. If it would have said f of 0 equals 3, then I would put a closed hole. But it doesn't say that anywhere. So that means f of 0 of 3, or that means that 0, 3 is not closed. So let's go over that again. If they would have given me something that looks like this, f of 0 equals 2, but if they would have said it equals 3, then that would have meant at 0, 3, I would have a closed hole. But they didn't give me that. So at 0, 3, it's not a closed hole. It's an open. So whatever has the F thing on it, that's the closed hole. Whatever doesn't, that's the open hole. And then it says the left curve is supposed to come in from the left and have a y value of 3. So this is what our picture is going to look like. We're going to have an open hole at 3, a closed hole at 2. For that 2, we're going to extend it to the right to talk about the right curve. For that 3, that's for the left curve. So just kind of extend a left curve. Doesn't have to be too crazy. I think it's multiple choice. Okay, let's look at number, I think I deleted number 5. You're welcome. It was on accident. Okay, number 6, I was trying to delete, and it did get deleted. So now let's go to 7 and 8. So 5 and 6 will not be on your final. Okay, let's go to 7. 7 is a picture, and it says the limit as x approaches infinity. Well, first let's find infinity on the x. It's right here. Okay. And it's saying as our curve, as we look closer and closer to when x is infinity, what is this curve doing? So this curve, as we look farther and farther to the right when x is infinity, it looks like this curve kind of levels off because it's going side to side. So let's see where it levels off at. I think it was -1, -2, -3. So the y value for this yellow curve is -3. Well, what is a limit? The limit is the y value. So as x approaches infinity, my y value is just -3. Yeah. Okay, let's look for as x approaches negative infinity. Negative infinity is over here on the left. So we want to look at our curve that's closest to this negative infinity, which is this piece coming up here. Yeah. And if you look at that curve, it's going up and to the left forever. And so the question is, at the very end, when we have x is negative infinity, what is the y value of that arrow up there? Well, it's positive infinity because it's pointing up forever. So the limit of this sucker is infinity because it's going up forever. The limit on this right side was -3 because it goes down and then it levels off at -3 forever. So the first one was -3. The second one was infinity. Yay. Okay, let's look at number 8. Pretty much the same thing. It says limit as x approaches -1 from the right. Well, first let me find -1. Oh, it looks like it's this asymptote. Okay, this is -1. That's when x is -1. Now it says we need to look from the right, from the left, and then we need to consider both. Okay, so from the right, we don't need to find the piece of the graph all the way to the right. That would be if x is infinity. We need to find the piece of the graph that is directly to the right of this x equals -1. So if I cover up this graph and I look at when x is -1, it's this up and down line. The piece directly to the right of it, is this piece that's going down. Yeah. So as we come in from the right side of this graph and I trace over, I go up all the way up here, then I come back down here, and as I get closer and closer to that yellow line of x equals -1, my y value goes all the way, down to -infinity. I think I was flipping you off. I did not mean that. Okay, now let's look at this. X approaches -1 from the left. So here's my -1, that yellow line, and I'm gonna look for the piece of the curve that's directly to the left of it, like right, you can barely see it. Gosh, okay, but it's right. Yeah, you could barely see it. So, here's this -1 where x is -1, and directly to the left of it is this green. Directly to the right is this purple. So directly to the left is this green, and as we come closer and closer to that x value of -1, the y value goes zoom all the way up into the air to infinity. Then when it says, what's the limit of just x equals -1, we consider both the past two answers, and if the past two answers match, then that's our answer. But they don't match. One's positive, one's negative. So, darn, that sucker does not exist. poo. All right, let's keep going. Let's look at number 9. It says f of x equals 2x over x minus 9. And then it says, what's the limit as x approaches 9? Negative, positive, and then just 9. Well, let's remember that 9 negative means the left. 9 positive means the right. Just regular 9 means you consider both. Okay, well, if you try plugging in 9 into the bottom of this fraction, your calculator says error. So we're going to do something else. We're going to graph this. So let's go to y equals, and we're going to put this sucker in our calculator. We're going to have 2x divide sign, but then make sure you do open parentheses x minus 9. So I'm going to go to y equals, and I'm going to type this sucker in. If you have a alpha y equals, y equals button that has an n over d, you can type that in. But for those of you who don't have that alpha y equals enter with the n over d, I'm just going to type it with parentheses. So 2x divide parentheses x minus 9 close parentheses. Let me get rid of this weird fraction. Okay, now I'm going to go to graph. Graph. Yeah, and you can't really see it. I see one curve. But if you press zoom out, zoom 3, you can see that there's another piece of the curve. We just have to figure out where that piece of the curve is. So let me go back and press zoom standard. Okay, and then I think I'm going to draw this picture. So, our picture looks like, and then something like, yeah, okay. And I'm guessing that there's an up and down imaginary asymptote right here when x is 9. And they want to know what's the y value as we look to the left of 9. And we come really, really close to directly to the left of 9. Well, directly to the left of 9, it's pointing down, as in its y value is negative infinity. So that's for x approaches 9 from the left. From the right, we look at what's directly to the right of that 9. And you see that the curve is going up forever when it's closest to that 9. So when we're closest to this 9, it looks like it's a up arrow, and that means positive infinity. You don't have to put the positive. Then lastly, we consider both of those, and we ask ourselves, are those the same or different? Well, they're different. So it does not exist. Yay! Okay, let's look at the next one. Number 10. This one asks for the horizontal and the vertical asymptote. Okay, first let's type it in the calculator. And I press graph. And I don't have much to look at. I just got this sucker. Okay, let me maybe press zoom out. Zoom out. Number 3. And press enter. Okay, and I do have 2 curves. Okay, let me draw this. Okay, and okay, I didn't draw it very well, but good enough. Okay, so these are my 2 curves. I should have a vertical asymptote right in between these 2 curves, and then a side-to-side asymptote. But you can't see them on your calculator. We have to use our brain. So I think I'm just gonna maybe press the trace button and kind of just move my little spider, flashing spider left and right. So as I move my little flashing spider left, you can look at the x values at the bottom. And if you look at the x values of the bottom, right here, as I keep pressing my right arrow button, the x values went through negative, where'd they go? Oh, negative 3.6. And then they jumped to negative 4. And then the little flashy button pops up here. Okay, so I want to know, when is that break? What is that break? Well, we might be able to tell better from looking in our T-chart. Our vertical asymptote will have an error in my T-chart. So let's go to my table. I press second graph, and my vertical asymptote will have that error. And holy poop, it does. So for my vertical asymptote, you can find it from the T-chart. It's whatever has the error. Woohoo! But when you type it in, you don't just type -4 is your asymptote. You say x equals -4. So for your vertical asymptote, it's x equals -4. And that makes sense, because if I look at this picture, or this picture, it's kind of zoomed out, but it looks like this up and down line could occur at -4. Let me press zoom 6 to take me back to normal. And yeah, -4 is somewhere, 1, 2, 3, 4, right here, I think. Ooh, that was good. And yeah, that definitely looks like there could be imaginary boundary line that this curve can't touch. But I couldn't really see it, so I pressed zoom out, number 3. And then I couldn't really see it still, but I knew it was in the negative, so I looked to my T-chart and found the error. Okay, for the horizontal asymptote, that one's a little trickier. For the horizontal asymptote, you divide the big fat coefficients. And the big fat coefficients are the big fat numbers attached to the letters. So over on this 7x, the 7 is attached. Over here on this x, the 1 is attached. So the way we get our horizontal asymptote is we say y equals 7 divided by 1, or just 7. So my horizontal asymptote is at 7. And we can check that using our calculator. If we go back to our picture and I press trace, and then I press the flashy button, start moving the flashy button, and go over here to this top left curve. If you look at the y values, let's see, it's 26, 20, 17, 15, 14, 13. And then if I keep going, oh, look, it's going down. 9, 8, 6. Okay, yeah, it's gonna reach 7. It's just gonna take forever. And then if I look at the right side of my curve and get onto him, okay, just trace. No. Okay, if I look at this right side of my curve and press trace and start traveling along him, you can see that his y value is 4, 5, okay, it's getting 6, and then it'll get really close to 7, but it will never reach 7. See, the y value keeps getting bigger. Or if I look at my T-chart, we can see that, no, that's not a very good T-chart. I don't want to look at it. So anyway, yeah, if I press trace, the y value keeps getting bigger and bigger and bigger, and eventually it's going to go to 7. So my vertical asymptote I got from the T-chart. Huzzah, the error. Don't forget the x equals, or I'll only give you partial credit. For the horizontal asymptote, we divided these big fat numbers on the x's. Yay. Okay, let's look at number 11. It says, what's the limit as x approaches negative infinity? Well, anytime you have negative infinity here, you plug it in to just the first piece of every equation, or the first piece of the top and the bottom of an equation. So I'm gonna have 40 negative infinity to the 5th all over 15 negative infinity to the 4th. And then now I'm going to just kind of use my brain. If I have a negative and it's raised to a 5 power, let's think. Negative times a negative, that's a positive. And then another 2 negatives, that makes a positive. But then if I tack on another negative, that means positive from the first 2, positive from the second 2, and then negative on the last sucker, and those multiplied to a negative. Anyway, so this negative number, whether it's infinity or another number, it spits out a negative. On the bottom, a negative raised to an even power spits out a positive. And then lastly, a negative divided by a positive is a negative, and then you throw an infinity on it. I know that seems like I made it up, but it's true. So anytime you have x approaches infinity, and we got some formulas, we got an equation, we're going to plug in that negative infinity. And then just think about, what sign is it going to be? Well, no matter what I put into parentheses, if it's negative and I raise it to the 5th, I still get a negative no matter what's in the air. Yay. So negative infinity to the 5th is just a negative. Okay, let's look at number 12. I think we have to draw a picture. It says f of 2 equals 1. So that means we're going to have a closed hole at 2, 1. Okay. Then it says the limit as x approaches 2 is 1. That means that the y value is 1. But from which side? The left, the right, or both? Well, let's remember, if you don't have a minus or a plus in that top right, it means both. Okay, so let's draw a picture. At 2, 1, you're definitely going to have a closed hole. So 2 to the right, up 1, we're definitely going to have a closed hole. Yay. Then, because it says the limit as x approaches 2 is 1, that means when x is 2, my y value is 1, but it's for both sides of the curve, as in both sides of the curve. So when you look for your picture, you should look for when we have a closed hole at 2, 1, and then both sides of that closed hole are connected. So if I look at our pictures, I'm looking for a closed dot at 2, 1. This one has an open dot, so that's wrong. This one has a closed dot, so that's right. 2, 1. This one has an open dot, so that's wrong. This one has a solid line, and that's like a bunch of closed holes. So this letter D, you can't really tell, but at 2, 1, it's just a line. But on lines are actually made out of thousands, bagillions of closed holes. So I can put a closed hole on this answer D because it's a solid line. And then look, that kind of looks like my graph. I got a closed hole at 2, 1. I got a closed hole at 2, 1. And then both sides of the curve are connected to that closed hole. So part D, both sides, the up and the down, are connected to that closed hole. So that's our answer, D. If we look at B, at 2, 1, it looks like I'm connected from the left. See this left? But then the right is way down here, and that's not correct. They're supposed to be connected. Okay, and then it says, is f of x continuous at x equals 2? Well, it's only discontinuous if you have an open hole right there, but we don't. So the answer is yes. Because there's a closed hole right there, and our two curves are connected to that closed hole from both sides.